Good afternoon, ladies and gentlemen. It is David Schlotthauer here in the home weather office with another detailed El Nino update for May the 15th, 2023. In this video, we will be discussing about how strong El Nino will get, and we're going to explain what is El Nino and how it impacts the atmosphere. So as always, I always like to visit the PowerPoint here that NOAA makes every Monday. And so this is going to have more new information with it, new chances of how strong El Nino is actually going to get. So this was updated as of May the 15th, which is today, which is why I make these videos every Monday, because we have new information. So let's take a look here first at the third slide here. The latest summary is that we do have an El Nino watch that is issued. That is a guarantee because we are seeing near to above average sea surface temperatures across most of the Pacific Ocean. And there is now a 90% chance that El Nino will be persisting into the northern hemisphere winter. In fact, to be specific, there's a 95% chance that that will actually end up being the case. So what I'm telling you here is there is definitely a likelihood that we will have El Nino conditions even by late May or even June. Even specifically, we have El Nino conditions already in place in the Nino 3.4 region, which we will look here in just a second. So here's a look at the recent evaluation of equatorial Pacific sea surface temperature departures. And we can see clearly there has been quite a bit of warming that has been taking place here ever since early March. To be specific, it really initially started in early February and really has gotten to be pretty significant now, anywhere between 2 to 3 Celsius of waters off the Peru coast. Those waters are moving rapidly westward because of the weaker trade winds, and that helps El Nino to really get going. And so when we take a look at this here, our Nino region sea surface temperature departures recent evaluation, and I've talked about this in recent videos. These different thumbnails, these different areas here indicate different regions. So I'll do this again. So El Nino 4, okay, is in yellow. Okay, that's the yellow box. The El Nino 3.4 region is the black box. It's outlined in black here. Okay, so I wanted to make sure you guys can see that. All right, and then the El Nino 3 is the red box. And then the El Nino 1+2 is the white box. Okay, it's the outline here. It's the Peru one, the one that has the warmest sea surface temperatures. So now that you see these regions very well on the thumbnail down here, we can clearly see that the El Nino 3.4 region is now in El Nino thresholds, 0.5 Celsius above the long-term average. And you want sea surface temperatures to be 0.5 Celsius above average to declare a weak El Nino or greater. So the El Nino 3 region is 0.9 Celsius above the long-term average, which is almost in a moderate El Nino territory. To be specific, the El Nino 1+2 region is in a very strong El Nino territory, but this 2.4 will have to make it over to the El Nino 3 region, which is still quite some distance away. But it is encouraging to see that this number here is now 0.5 Celsius above average. And we can also see that reflected in our past sea surface temperature anomalies. See all these upward trends here, indicating that there is still warming taking place in the Nino region indexes, including the Nino 4 region, which is slightly above average, no longer in a La Nina state at all. So we have really transitioned out of La Nina, out of neutral, and now we're beginning to see El Nino conditions really taking hold. So this is a look at the latest sea surface temperature from the NOAA Coral Reef Watch Daily 5-kilometer sea surface temperature anomaly version 3.1. And what this is showing us is in the last 31 days. So over the last month, and we can see how sea surface temperatures have evolved since then. See all this warming? Take a look here at the last week, right at the end of the slide, or the end of the animation, or the GIF. A indication that El Nino is strengthening. We have even seen some warming out here in the Central Pacific, south of Hawaii, which is encouraging signs to see. In fact, it is already about a degree Celsius above normal in that localized area. Still very warm here off the Peru coast, anywhere running between about 3 to 4 Celsius above normal. We've lost the 5 Celsius, which is encouraging to see, because that was really significant. That was quite, I've never seen anything like that. So now that we took a look at our sea surface temperature anomalies, what's going on below the surface? Okay, so we're just going to kind of dive deep here, and we're going to look down to about 100 meters, 50 meters, 200 meters. So what is going on below the surface? Subsurface temperatures. And so the reds here indicate that sea surface temperatures are running well above average, not just at the surface, which is up here. I'm going to box this in black. Not just up here, but down here is where we're seeing a lot of the warming. A lot of the upper ocean heat content really materialize. So ever since May, there has been this very warm, anomalous waters, anywhere between 3 to 5 Celsius, still 5 Celsius below the surface of the ocean near Peru. So the question is, will that surface? And due to the fact that our trade winds have slackened, we're not seeing much of that really taking place. But we have more than enough water out here below the surface of the ocean to initiate a moderate to strong El Nino, perhaps even a very strong one. Possibly 2 Celsius by the winter time in the 3-month mean. That cannot be ruled out. All right, taking a look here at our equatorial temperature map here, and we can see clearly with what we are seeing here, definitely a lot of upwelling that has been taking place, not far below the surface. So it will be interesting to see if that continues, right? But recently, we've seen a backward jump in the thermocline index, which you can see here. A lot of this warm water is sloshing over towards the east, and that's helping to initiate this El Nino. So kind of backtracking here, I just realized I forgot some other things of the PowerPoint. Really quickly, I did want to show you all the Central and Eastern Pacific upper ocean 0 to 300 meter. Definitely above average here. Has cooled off a little bit in recent weeks, which is probably a good sign, right? Because if this were just to go straight up, I don't know how much higher it could go. But it is definitely warmer nevertheless, and it is warm enough to actually initiate a moderate to strong El Nino by early fall to early winter. So we just looked at this, so we're just going to kind of skip it because it reflects this right here, okay? So we're going to go to our wind anomalies, and they are pretty much average. We have not seen any coincidence here of westward wind anomalies at the 850 millibar level. So what we're looking for here is these winds that blow from west to east in the 850 millibar level. Now, these are anomalies, so you're not going to see this on a numerical weather map, all right, like the GFS. What this illustrates is, are the trade winds stronger than normal? Are they weaker than normal? In this case, they are about average. We're not seeing a slackening of the trade winds at the 850 millibar level or at the surface. They are blowing pretty much average at the moment, but we're waiting to see if there will be some reversals here, and some of the models do indicate that will happen by late May, early June. The 200 millibar wind map here anomaly is pretty average. We're still seeing the enhancement of that Walker circulation, still that westerly wind at 200 millibars. We're waiting to see that relax and blow more out of the easterly direction at that level, which is at about 38,000 feet. So when we take a look here at our weekly heat content evolution equatorial Pacific, Definitely some strong Kelvin waves that are in place. We're waiting for another Kelvin wave to take shape here within the next week or so. Each Kelvin wave really helps to initiate a lot of the warm water across the eastern Pacific and the central Pacific. And so probably soon here, we will see another Kelvin wave get going. And we can see that here. Westerly wind anomalies really strong here over the near the international date line, also across Indonesia and the Western Pacific. And so what we're going to see here is, does these westerly wind anomalies actually make it all the way over to the Eastern Pacific? And if they do, that's going to help to really booster or bolster the sea surface temperatures quite well. This is coincidental with a very strong MJO phase that is still in progress right now as of this video, the 15th of May. And going forward here, we can clearly see that they did fill in another box here, negative 0.2 Celsius. So we are inching closer to the El Nino threshold. Now, just because we are at 0.5 Celsius in the Nino 3.4 region right now, we have to wait for at least 3 to 6 consecutive months, or kind of blended months, for them to declare an actual El Nino in place. That could happen, though, by, say, September, October, and November, depending on how quick we warm things up, which we really are starting to warm things. So right now, as of this, in the last 30 months, roughly 0.2 Celsius above the long-term average in the Nino 3.4 region. So we just talked about this. Let's talk about this now. So basically, this is the CFS, or the Climate Forecasting System version 2 model. And this is kind of showing me how warm El Nino might become by the fall and winter time of 2023 and 2024. So most of the models here do indicate that we're heading uphill here. Look at this black line, a illustration of that we are going to get quite close to 2.5 Celsius, which is needed for a super El Nino. So given the fact that models are slowly backing down on this, we're probably going to be looking at a moderate to strong El Nino event, which is still very significant in its agricultural impacts across Australia, across Indonesia, even for India, which is really having a dry start to their monsoon season, thanks to El Nino conditions that are beginning to shape up. So I only imagine of what this is going to mean down the road for the U.S., as far as droughts in other places and lots of rain in other places. So right now, most of the models do indicate that we are still on the verge of a possible super El Nino for late fall, early winter. But due to the blended average here, based on all the ensembles here, we're probably looking at a strong to a moderate to strong El Nino event. So kind of something in this ballpark, probably from right about in here, probably to right about here. So probably a moderate to strong El Nino event is probably more appropriate in this video, but does not surprise me if we have another one of those significant warming events where this might get a little higher. So just keep that in mind. We are running ahead of 1983 or 1982, 83, 1997, 98 with those two El Ninos, and we're even running about like we were back in 2015 and 2016 of that El Nino. So just for reference, all right? So basically what I'm saying is we are definitely on par to seeing a pretty significant El Nino event, perhaps by this fall and winter time. So now, another tool that I like to use here is the GFS model. Now, this is kind of, just take this with a grain of salt, folks, when you see maps like this, because the GFS model is not a climate model. It's just a global model, and it does not resolve long-term weather conditions very well. So when we go and take a look at this, what you're going to see here on the GFS model, if this fully rendered, and it did, what you want to see here is lower than normal pressures over the Central Pacific. So for reference, this is Hawaii right here. This is the United States over here. This is Australia. This is Indonesia. This is Africa. and this is Peru and Central America. Do you follow me on that? Do you guys see with what I'm talking about here? Hopefully you all do, okay? So what I'm looking for here on this map is a pressure difference between Darwin, Australia, which is over Indonesia, over the Indian Ocean, and a pressure difference towards Tahiti, which is over here. So when you get lower than normal pressure over Tahiti than in Darwin, it is a strongly negative Southern Oscillation Index, which we will be looking at here in just a little bit. So when we take this forward here, you can see how the pressure pattern here is very much like a neutral, possibly a weak to moderate El Nino. You got lower pressures over the Central Pacific, and you got higher pressures over Darwin, Australia. Okay, going forward, we can see here, let's take this forward, definitely turning more negative. Look at this. Within the next 6 to 7 days, perhaps, very strongly negative Southern Oscillation Index. You can see the pressure pattern over Tahiti would be very, very low versus in Australia, very, very high. So it'll be very interesting. If that sticks around, we could see a very, very strong negative index, possibly negative 40, negative 75 on the index, which means lower than normal pressure, weaker than normal trade winds over the Central Pacific, and stronger than normal trade winds usually over the Indian Ocean, which means a weaker monsoon for that reasoning. Follow me on that? And then going forward, we can see how this really sticks around for the entire forecast, a real negative phase. Look at that, a super typhoon maybe in the Western Pacific. That will be for another video later on. If that actually happens, would be very significant, to say the least, over portions there of near Taiwan, near Philippines, would be a very strong system. So now that we talked about the GFS and what the SOI means, here's a look actually at the observations. So again, when pressures are higher than normal over Darwin, Australia, and they're lower than normal over Tahiti, you get a negative phase of the Southern Oscillation Index. And we can see that really reflected here. We saw it went down to negative 31.31 literally on the 12th of May. It has come up a little bit, but we're about to get another significant negative outbreak of the Southern Oscillation Index towards the end of May, early June, and it will be interesting to see how low the 30-day average will get. Right now, it is at about 5.99, and the 90-day average is already at negative 1.43. So we are definitely not in a La Nina state anymore in the Southern Oscillation Index, and we can see how this really has tumbled recently. And May is being the bigger month, of which we're seeing a big tumble of the Southern Oscillation Index. All right, so that's what this is showing us. So right now, the latest contribution is pretty much still slightly lower over Tahiti than in Darwin, which has contributed to negative 12.47 on the daily contribution. So now that we talked about the Southern Oscillation Index, we talked about what El Nino is, all right, but exactly what is El Nino? Why is it so important? All right, so we're actually going to switch things around here. All right, so again, we're going to talk about what this guy is doing here in the Eastern Pacific and why it impacts our weather pattern. So when we take a look at this, this is El Nino conditions. So essentially, you get stronger westerly wind bursts. This is not what the diagram actually means, right? This is basically kind of a rough example, but it basically follows the same properties. The Walker circulation is very weak to non-existent, and so you get westerly wind bursts over the Western Pacific, over Indonesia, and you get weaker trade winds over the Eastern Pacific, including even the Central Pacific. And then you get this upward motion that occurs. When that occurs, you expel a lot of the heat in the atmosphere. So a lot of the heat kind of moves from the equator over to the poles. It helps strengthen these jet streams in that manner because, well, when you release heat in the upper atmosphere from down below, that air has to go somewhere. And so when you have a strong jet stream to begin with and you add more fuel to it, it's just going to get more stronger. So basically, El Nino is essentially weakening of the trade winds and a stronger than normal jet stream in the winter months. Versus neutral conditions, we can see we typically get upwelling of cold water from below the surface. We get a lot of warm water or downwelling in the Western Pacific because the trade winds here are much stronger than average. So you get a lot of your lower pressure rising motion in the Western Pacific, and then you get sinking motion over the Eastern Pacific, which is why you don't get much hurricanes in the Eastern Pacific, but during the Atlantic hurricane season, you get more activity because there's not really a lot of shear to contend with. Follow me on that? So this is why El Nino is so important, because it changes our weather pattern, not just at the equator, but also in other places. That's why Australia and India can get serious droughts because of the lacking of the rainfall that you all get because of El Nino conditions versus La Nina, which enhances it. So when you take a look at this, this is a diagram from the National Oceanic Atmospheric Administration, and you can see the jet stream here stronger than average during El Nino years. So you're going to get more wetter than normal conditions across California, the desert Southwest, and the deep South, including for the Southeast. It's typically drier than normal over portions of the upper Midwest, and it is warmer and possibly dry too across the Pacific Northwest and the northern tier of the United States. That's the opposite during La Nina conditions, where it's colder than average, which you have seen a fair share of that, especially over California and much of the West. It is usually wetter than normal across the Pacific Northwest, which didn't even pan out this year. You've had a below average rainy season, and it is typically drier than normal across the desert Southwest, the deep South, and the Southeast, and wetter than normal conditions across the upper Midwest and the eastern seaboard. Well, that is going to conclude today's detailed El Nino update for May the 15th, 2023. I hope you all enjoyed this video very much. I hope I did a great job at covering as much detail as I can in this video. If I did, please consider subscribing, hitting the like button, and sharing this video with your family and friends on social media. And never forget to also leave a like and check out all my social medias. Those links are in the description below this video. But otherwise, have a fantastic rest of your day, and I will be back here again this afternoon with another hurricane or with another video, and we're going to be focusing on the Atlantic hurricane season, which some of you have been waiting patiently for. So I'll have 2 videos out today.